Hello everyone and welcome back to a new video. So in this video I will show you a few tips on how to improve your Python code by making it faster, cleaner and more efficient. Now these tips are beginner friendly, simple to understand and implement, and once you start applying them in your own Python projects, you will see a noticeable improvement in your Python coding skills and style. Now I grouped these tips under 4 topics. We have vectorization, comprehensions, built-in functions, and finally iterators and generators. And I will discuss each topic while showing you examples to better understand what we're talking about. And as usual, I will put in the description the link for the Jupyter notebook, as well as any other references or documentation I may mention. So without further ado, let's get started. So here we have the notebook. We will start with the first topic, vectorization. Vectorization is actually the concept of operating over, let's say, vector objects, instead of looping over elements to perform calculations. And as you may know, the loops are a common performance bottleneck in Python, especially when working with large datasets. And that's because Python is an interpreted language, so the loops are much slower than compiled operations, and that's why we should prioritize using vectorized operations from libraries like NumPy, TensorFlow or PyTorch. And that's because they run the operations in an optimized fashion using C or CUDA code for GPUs, which make the computation much faster and the code more concise. So it's important to always check if a vectorized version of an operation exists in a library before implementing it with loops in Python. Alright, so now let me show you a few examples of these vectorized operations and their impact on the computation time. So let's start first by importing NumPy. Alright, so now we need 2 lists to work with. So let's first define their length. Let's put 1 million. Then we define the first list and then the second one. Alright, so now let's see the impact of the vectorized operation on a simple addition operation. And here we will use the timeit magic function to print out the execution time. And then let's create a new list, which will be equal to the sum of both lists. And to calculate it, let's create a for loop. And then we append the sum of elements from both lists. And let's run the cell. So as you can see, this is the execution time for this operation. Now let's see the execution time for the vectorized addition operation between vectors. So we will convert both U and V lists to vectors, and we simply add them using the plus operation. And as you can see, the same operation is computed in about half the time. Now let me show you another example in machine learning to better understand the impact of these operations, for example, in the training of a machine learning model. So let's take, for example, the multiple linear regression model. In this example, we need to import the time library to compute the process time or the computation time for the training process. So let's start by setting the number of samples and features. Let's say we have 100 samples and 5 features. Then let's create the feature matrix. So it will be of shape 100 lines and 5 columns. After that, we need to define the target variable. So let's define it as a linear combination of the features. So let's say we take 1 plus 2x0 plus 3x1 minus 4x2 plus 5x3 minus 6x4, and then let's add a small noise to make it more realistic. Alright, so then we need to add the intercept column to the feature matrix. So let's call it x-intercept, and we will stack a NumPy array of 1s to our feature matrix. Okay, so now we're ready to create our training loop. Let's set the parameters first. So let's start by initializing the weights vector. Then we set the learning rate to 0.01. And then let's take a big number of iterations to better see the impact on the computation time. So let's set it to 10,000. Alright, so now let's create the training loop. So let's start by calculating the predictions. So we do that by calculating the dot product between the feature matrix and the weights. Then we calculate the error, which equals the predictions minus the actual target value. Then let's calculate the gradient, which is given by this formula for the model of multiple linear regression. So we have 1 over the number of samples times the dot product between the transpose of the intercept matrix with the errors. And finally, we update the weights using the gradient descent formula. So we subtract from the current weight the gradients times the learning rate. Alright, so now the training loop is complete. Let's add the starting time and the finish time. And then we can print, for example, the estimated coefficients using gradient descent. And we can also print the computation time. And that would give us the time in milliseconds. Alright, so this is the computation time for the vectorized version of training a multiple linear regression. So now let's use loops instead of the vectorized operations. So let's copy this code. And then we need to modify the training loop. So we will loop over the number of iterations, of course. Then since we will be working with lists instead of NumPy arrays, we need to initialize the gradients in each training iteration. So let's create the gradients list. Alright, so now let's loop over the training data. Then we need to compute the prediction for this instance of the training data. And to do that, let's first initialize the prediction to 0. And to calculate the dot product between the feature matrix and the weight vector, we need a for loop to do that. And if you're not familiar with the dot product, this is how it's actually calculated. Alright, so now we have the prediction. We need then to compute the error, so we calculate it as such. So the error is the prediction minus the correct value. And then let's calculate the gradients and update the gradient vector. So here we calculate the gradients with respect to each weight. And then, as we did before, we need to divide the gradient vector by the number of samples. And for that, we need another for loop. Alright, so now the final step is to update the weights or the parameters of the model. So we loop over the theta vector and we update it using the gradient descent update rule. Alright, so I think this is it for the training loop. Let's run this cell and see the computation time. Alright, so as you can see, it took about 5 seconds to perform the same task. And that's why we need vectorization, especially in machine learning and deep learning. And by the way, if you're familiar with linear algebra, there is a more compact and vectorized form for multiple linear regression called the normal equation. And that's using the inverse of matrix operation. And you can derive it as such. So we can calculate the value of the weights in one line. And what we do is to calculate the inverse of the matrix, that is the product of the feature matrix transposed by the feature matrix. And then we multiply it by the product of the feature matrix by the target vector. And here, by the way, the at operation is a matrix multiplication. And as you can see, we get the same results. Alright, so that's it for the vectorization. Let's move on to the comprehensions. And actually, if you've noticed it, we already used it to initialize the gradient vector or list here. So it actually presents a way of creating lists, dictionaries, sets, and generators in a more concise fashion in Python. They also tend to run faster because of their optimized implementation. And from my own experience, I noticed a boost of up to 10% in the computation time. So let me show you a few examples. So let's start with the list comprehension for the first example. So here we will use again the timeIt magic function. So let's initialize a squares list where we will calculate the squares of numbers. And let's loop over a huge number, let's say 10 million, and append to the squares list the square of each number. Let's run this cell. Next, let's try the same operation, but now let's use the list comprehension format. So to do that, we simply create a list, and inside it we embed the for loop. So we write it like this. And as you can see, we have a slight improvement in the execution time. Now that slight improvement could accumulate to much more. Let's say if we're using a lot of loops or embedded loops. So that's why it's better to use list comprehensions when it's possible. And we can do more with the list comprehensions. We can embed if statements. So for example, if we want a list containing only the pair numbers from the square list we just created, we can do it as follows. So let's create the squares list again. And then we can create the pair numbers list. So we take the elements from the squares list if their mod 2 equals 0, and we can verify by printing the list. We can also take it one step further and include one more loop in our list comprehension. So let's say we have a words list containing, for example, the words hello, word, this is a test. Next, let's say we want to extract the characters from each word of length bigger than 3, and we create a list out of those characters. And to do that, we can simply create a new list where we loop over the words in the words list, and if the length of the word is bigger than 3, we take the characters of that word by looping over the characters in the word, and we can print the result to verify. So there it is, we have the list of characters. And the same can be done with dictionaries, sets, and generators. So let's see the second example with generators and dictionary comprehension. So let's, for example, repeat the previous example, but this time with generators instead of lists. So the only change we need to make here is to use parentheses instead of the square brackets. And as you can see, when we print the variable, we get generator object, and we can then view the next element in that generator. So this is the first element, and we will talk more about generators later on this video. As for dictionaries comprehension, it's quite similar also to lists. The only difference is that we're handling two variables representing the keys and values. And one common example is to reverse a dictionary. So it's pretty simple, and let's say we have this dummy dictionary which contains, let's say, key 1, value 1, key 2, value 2, and key 3, value 3. Now let's reverse this dictionary. We can do it simply by reversing the key and value variables. So we create it as such, and we loop over the key and values in the dictionary1 items, and this is the result. Alright, so now let's see another example where we can utilize comprehension, for example, to create prompts for LLMs. So I have this small dataset of product feedback, and we're going to use it in this example. So let's first set the file path. Then let's say we want to give those feedbacks to a large language model to ask, for example, for the average sentiment about our product. And to do that, we need first to get the list of feedbacks and integrate them in the prompt. So we will do that first without comprehension and then with comprehension to see the difference. So let's create a filtered feedback list where we would only take, for example, let's say the feedbacks with more than 5 words to actually get the more important ones. And then we open the feedback file. we loop over the lines in the file. Then we can, for example, strip the line and split it into words. And then, in case the length of the words is bigger than 5, we append it to the filtered feedback list. And then we can convert the filtered feedback list to a context string using another for loop where we join the filtered feedbacks together with a new line character as a separator. And we can print the context. Now let's see how we can recreate this same code or the same example using comprehensions. So we create a list, and in that list we will loop over the lines in the file. So we write line for line in open feedback file with the read mode and the encoding. And then we can add the strip method to the line, and we filter for the feedbacks with more than 5 words. And that's how we create the filtered feedback list. So as you can see, it's basically in one line of code. And then we can create the context. We can also create it with the join method for strings. And we can print the context to get the same result. So as you can see, the comprehensions not only make the code run much faster, but also looks cleaner and more concise. And that's why I would advise you to use them whenever possible. Alright, so now let's move to the next topic, the built-in functions. So these functions are implemented in C and optimized for performance. So you can use them to greatly simplify your code and improve the speed. And by the way, here I'm not talking about the most common built-in functions like print, length, type, and range, etc. Instead, here I'm only covering the top 3 functions that I find very useful and that I usually use in my machine learning projects. So let's start with the first one, the map function. So let's see an example of the map function. So here we have the words list from the previous example, and let's say we want to apply the upper function to all the words in that list. And to do that, we can use the map function. So we define the upper words equal map, and we pass the string.upper function, and then our iterable, the words list. The map function would apply the first function that we passed, the string.upper, to all the elements in the words list and return a map object. So we can print the upper words to C. So here we have a map object, and then we can convert it to a list to get the result we wanted to see. So here it is. We can also pass a custom function. So let's say we have a list of feature values, and we want, for example, to normalize these values. So let's define the min-max scaling function, where it takes a value with a min and a max value, and then we return the normalized value of x. So this is a custom function that we can use with the map function. And to do that, let's create the normalized value list. Inside it, we create a map. And for the function, we can use a lambda function. And then we pass our iterable, the feature values. So what's going to happen here is that it's going to apply the lambda function to all the elements in the feature values. And those elements will be passed as the x variable here to the min-max scaling function. And let's print the result to see if it actually worked. Alright, so now let's move on to the next function, or built-in function, which is the filter function. And this works quite similarly to the map function. So here, let's say we have the words list again, and we want to filter out the words that have less or equal to 4 characters. So to do that, let's create a new variable, big words. It's equal to filter, and we first pass the function that will be used as a filter. So we define a lambda function, and this function should return a true or false value. So let's say we define the filter as len word bigger than 4, and then we pass the iterable. So then let's print the result. And as you can see here, the new list contains only the words that have more than 4 characters. Alright, so the next built-in function is the sorted function. So this is used to sort an iterable based on a custom key. So let's say here we have a list of, for example, labels and confidence score. And let's say we want to sort our predictions based on the confidence score from higher confidence to lower confidence. To do that, we can simply use the sorted built-in function. We first pass the iterable. So here we pass the predictions. And for the key, we can create a lambda function that returns the confidence for each prediction. And we set reverse to true to get the sorted predictions from highest to lowest. So as you can see, first we have bird with 0.92, then cat, then dog, then fish. Alright, so now let's cover the last category, the iterators and generators. Now the iterators and generators are very important when dealing with large datasets. They basically allow us to handle data in a lazy fashion, meaning that we can generate items on the fly rather than loading the entire dataset into memory. And let's start with an example on generators. So to define a generator, basically we can define it like a function, but with a yield statement. So let's say we want to import the dataset using a batch of size 2. To do that, we define our feedback generator, where we pass it the file path and the batch size. So let's then initialize the batch variable as an empty list. Then we open our feedback's dataset file. And we can loop over the lines in that file. And we append the lines to our batch. And if the length of the batch equals the batch size, we yield the batch, which means that we return the batch when the function or the generator is called. But actually the return statement terminates a function and sends the single value back, whereas the yield pauses the function, which makes it a generator, and sends the current value, allowing it to resume later on when it's called again. And after yielding the batch, we need to reinitialize the batch again with an empty list, so that once we call the function again, we can create another batch using that empty list. And then once we finish looping over all the lines, if we still have a batch, meaning that the batch isn't complete, isn't filled to the batch size we indicated, we yield it nevertheless because we want to get all the data in the dataset. So that's how we define the generator for this task. And let's try, for example, with batch size of 2. So we create our generator using the file path and the batch size. And then we can loop over our generator and print each batch. And as you can see, here we have all the batches from our dataset. And that's how we can define generators to load data on the fly. And by the way, as you may have noticed, I didn't use any comprehension when defining this generator. That's because I wanted to be very simple to understand and quite straightforward. But we can redefine this generator using list comprehensions and generator comprehensions. And we can do this as such. So let's copy the code for this generator. And then we will modify this part. So what we'll do here is we will create a generator expression for the lines in the file. So we created using the generator comprehensions lines equal line.strip for line in file. And then what we need to do is duplicate this generator. So we can create a list containing the lines generator and then multiply it by the batch size. And then what we need to do is to unpack the list of generators and zip it together. So this way we would have the same generator represented in couples, and we can iterate over those couples. So let me show you a quick example. what we're talking about here. So let's say we define this generator L equal I for I in range 10, and then we zip that generator with itself and we loop over it. So for I in zip LL, and we print I. So this way the element I is a couple. So as you can see here, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the structure we want to get for our batches. So to achieve that, we created a zip where we duplicated our lines generator using our batch size, and we unpack it so that we can zip it. And then we loop over it to get our batches, and we yield from this new generator. And that's basically how we can define it in a more concise manner using comprehensions. And then of course, if we have remaining lines in our generator of lines, we can return it. So we define the remainder from our lines generator, and we yield it to get the remainder of lines. So let's run this cell. And as you can see, we get the same result. We can convert the batch to list to get the same exact results, because here we have the batch as a list. But you get the idea. So alright, now the last thing I will cover is the iterators. But more specifically, I wanted to cover the iterators from the Iteratools, which is a library that comes with Python. So basically, the iterators are Python objects that have what's called an iterator protocol. Basically, in simpler terms, if we define a class containing both the iter and next special methods, then that is considered an iterator. For example, let's define here a new class. We call it myIterator. Then let's define our constructor. So we want this iterator to count from a number A to a number B. So we give it a start and an end variables. Then let's set the current attribute to start and the end attribute to end. So then we define our iter special method, and this method returns the iterator itself. And then we define the special method next, and this is where the computation occurs. So if the self.current is bigger than the end, then we raise a stop iteration, meaning that we want to stop the iteration when reaching the end. And if that's not the case, we want to return the current value and then increment it. And to do that, we need to create another variable. Let's call it value. We assign it the current value, and then we increment the current value and return the variable that we just created. And that's how we create an iterator in Python. So now let's try it. So let's define myIter as an iterator that counts from 1 to 5. And let's loop over the iterator and print the numbers. And as you can see here, we have the iterator counted from 1 to 4. So this is how you create your custom iterator in Python. But I wanted to cover some iterators from the Iteratools library that comes with Python. So let's import it. This library contains predefined iterators that are very useful in many cases. And let's see a few examples on that. So let's start with the chain and chain from iterable iterators. So first, let's take an example on the chain iterator. So let's say we have a list of feedbacks. So here we have feedback 1 and feedback 2. And then let's take the filtered feedback generator that we defined in a previous example. And since we can loop over a list and we can loop over a generator, then we can merge them together using the chain iterator from Iteratools. So let's create the chain object merged equal iteratools.chain, and we pass the feedback 1 and filtered feedback. And now let's print merged as a list. So as you can see here, we have a list containing feedback 1, feedback 2, and all the elements in the generator from filtered feedback. And that's how we can use chain. We can use it with any type of iterables in Python. Then let me show you an example for chain from iterable. Chain from iterable does the same thing as chain, but it actually takes as input an iterable, which contains multiple iterables. So let's take again our filtered feedback generator, and let's create a nested list. So this list would contain the feedback1 list and our filtered feedback generator. So this list contains another list and a generator, and we can flatten the nested iterables using chain from iterable. So simply we create our flattened chain object. So now we can print the flattened object as a list, and as you can see we get this result. Next we have the group by iterator, and as the name suggests, it performs a grouping operation. So let's say here we have a list of feedback with the predicted sentiment for each feedback. Alright, so then we can use group by to group these feedbacks by sentiment. And to do that, we use the itertools.groupBy, and we pass our iterable, which is the list of feedbacks. And for the key, we can use a lambda function which returns the sentiment for each feedback. So we can then loop over this iterator. So this iterator would contain two variables, the sentiment and the group. And let's print first the sentiment and the list of feedbacks in that group. Alright, so as you can see here we have the positive group containing great service, neutral containing average experience, then negative containing not worth the price. Then again we have another positive group containing fast delivery. And that happened because we didn't sort our iterable before passing it to group by. So if you want for group by to work as intended, you need first to sort the iterable. So to do that, we will simply use the sorted built-in function as we've seen earlier. So we create our sorted feedbacks variable, we use the sorted function, we pass the feedbacks, and we define the key using lambda function, which returns the sentiment for each feedback. Alright, so now let's run it again. And as you can see, we have the negative group, the neutral group, and then the positive group, and it works perfectly. Now the final iterator from Iteratools is called cycle, and it allows you to cycle through an iterable for an infinite amount of times. So let's say, for example, we have a list of API keys. So we have API key 1, API key 2, and API key 3. Then we can define our cycle iterator. So let's call it API key pool equals itertools.cycle, and we pass our list. And then we can create a for loop where in each iteration we change our API key. And to verify, we can print the request number and the API key used. And as you can see, we have the first request with the first API key, then the second API key, then the third, and then it repeats the cycle until we finish our for loop. So these are the Python tips I wanted to share with you. I hope that you found it informative and interesting, and see you in the next video.